Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Nor Hakimah binti Wan Abu Bakar. I would like to present my selected topic for assignment individual Bsr552, which is I choose this topic is Prestressed concrete. Introduction of Prestressed concrete. Prestressed concrete is a form of reinforcement concrete that breaks in compressive stress during construction to oppose those found when in use. It is a combination of steel and concrete that takes advantage of the strength of each material. Prestressed concrete is a structural material that allows for predetermined engineering stress to be placed in member to contract the stress that occur when they are subject to loading. It combines the high strength compressive properties of concrete with the high tensile strength of steel. Prestressed concrete was patented by San Franciscan engineer P.H. Jackson in 1889, although it did not emerge as an expected building material until 15 years later when a shortage of steel, coupled with technological advancement, made prestressed concrete the building material of choice during European post-war reconstruction. It can be used the floor beams, pipe, and railway sleepers, as well as structures such as bridge, water tanks, roof, and runway. Generally, prestressed concrete is not necessary for column and wall. However, it can be used economically for tall column and high retaining wall with high bending stress. Next, basic principle of prestressed concrete. First, the principle behind prestressed concrete is that compressive stress induced by high-strain steel tendons in a concrete member before loads are applied will balance the tensile stress imposed in the member during service. Second, larger pressurizing force are applied to the member by the tendons. High-bearing stress are developed at the ends by the anchoring device. The anchorage are generally designed to be means for use only for high-strength concrete work. Next, busting stress reliable at the ends of the beam cannot be satisfactorily resisted by low-strength concrete work. When stress transfer to concrete has to take the place by bond action, the concrete should have a high strength concrete. Shrinker crack will be very little when high strength concrete is used. Due to the high modular of elasticity of high strength concrete, the elastic and crack strength are very small, resulting in a smaller loss of prestress in a steel reinforcement. Type of prestressed concrete. There are two methods of prestressed concrete. For the first, pretension concrete. Pretensional concrete members are often precast in pretensional beds long enough to accommodate many identical units simultaneously. It is a placing of concrete around reinforced tendons that have been stressed to have desired degree. This method produces a good bond between the tendon and concrete, which both protects the tendon for corrosion and allows for transfer of tension when used in factory situation. The cured concrete adheres and bonds to the bar, and when the tension is released, it is transferred to the concrete as compression by static friction. We can see at the figure. Figure 1 is pretensional process, and that is example of pretensional hollow core plank being placed. For the second method of prestressed concrete is post-tension concrete. Post-tension concrete is a variant of prestressed concrete where the tendons are tensioned after the surrounding concrete structure has been cast. It is a technique for reinforcement concrete. Post-tension tendons, which are pressurized steel cable inside plastic duct or sleeve, are positioned in the forms before the concrete is placed. Once the concrete has gained strength, but before the service load apply, the cable are pulled tight or tension and ensure against the outer edge of the concrete. The type of post-tension concrete have two. The first, bone post-tension concrete. The second, unbound post-tension concrete. For the materials for prestressed concrete is: first, concrete and high-strength steel are used for the prestressed concrete. Second, the elastic modulus for prestressed concrete is much higher, and the elastic strength is smaller when the tendons are cut. Next, the highest strength concrete should be used for pre-tensioning to permit higher bond stress between the concrete and the cables. And last, for pre-tensioning and post-tensioning, the highest strength concrete is used for RCC members. Advantage and disadvantage for prestressed concrete. Advantage for prestressed concrete have 9. First, factory products are possible. Second, long span structure are possible, so that saving of watt is significant and thus it become economical. Third, prestressed member are tested before use. 4. The load are get counter balanced by eccentric prestressing. 5. It has ability to resist the impact. 6. It has fatigue resistance. 7. It has high life load carrying capacity. 8. It free from cracks from service load and enable entire section to take part in resisting moments. And the last, member are free from the tensile stress. For the disadvantage for the prestressed concrete have 6. First, requires skilled builders and experienced engineering. Second, initial equipment cost is very high. Third, availability of experienced engineers is less. 4. Required complicated formwork. 5. It required high-strength concrete and steel. And the last, prestressed concrete is less fiber resistance. Next, safety and healthy for prestressed concrete. First, alert manufacturers of prestressed concrete beams to hazards associated with strength restraint device. Second, it has cites that manufacturers should follow safety-related recommendations detailed in the Precast or Prestressed Concrete Institute's Manual for Quality Control for Plants and Production of Structural Precast Concrete Products. And the last, provide additional safety recommendations for employers who use strain-resistant device in the manufacturing of prestressed concrete beams. Challenges when use prestressed concrete. For the first, why prestressed concrete has not been used for as long in the United States as it has been in Europe. A few errors in design specifies and requirements have occurred which should not be replicated. For example, off-field prestress for include the use of lightweight aggregate as used in the Kenai River Bridge where the ginders create and spare steam curing when a metal sheet is placed inside a beam. The metal acts as a radiator and cools the concrete cover, causing cracks and not taken into account temperature differential on long casting beds. As in a New York reduced where ancient boards did not fit the temper after the beam was hoisted by crane. Next, most failure as the result of inadequate attention to small detail. Joint must allow for differentially thermal, creep and shrinkage in the connect member. These are all time dependent change. Next, bearing resistance may be reduced by axial force with serious breakage stress and often splitting of the concrete sheet on the beam. Prestressed member will change their camber with time, and some ratio freedom at the spot must be provided. Next, for the maintenance when use prestressed concrete. Suitable design and construct prestressed concrete structure have demonstrated great durability performance in different environmental situations, but there are situations in which prestressed tendon or prestressed concrete structure have extremely severe damage and deterioration. Suitable and appropriate maintenance method can be used with extreme care to maintain the strength and extend the lifespan of the existing prestressed concrete structure. They have not been damaged or deteriorated substantially. We can see at the figure 1 is structural deterioration in marine environment. Figure 2 prestressed strength at bottom flange seriously corroded and damaged. And figure 3 is prestressed concrete bridge deterioration. Okay, next application prestressed concrete. Uh, prestressed concrete can be applied at a bridge. Concrete is the most popular structural material for bridge, and prestressed concrete is frequently adopted when investigated in the 1940s for use on heavy-duty bridge. The advantage of this type of bridge over more traditional designs was that it is quicker to install, more economical, and longer lasting, with the bridge being less lively. In short span bridge of around 10 to 40 meters or 30 to 130 feet, prestressing is commonly employed in the form of precast, pretension, girders, or planes. Medial length structure of around 40 to 200 meter or 150 to 650 feet. Typically use precast segmental, in situ balance, cantilever, and incrementally launched design. For the longer bridge, prestressed concrete deck structure often form an integral part of cable steel design. Second, prestress can be applied at dams. Concrete dams have used prestressing to counter uplift and increase their overall stability since the mid-1930s. Prestressing is also frequently retrofitted as part of dam remediation work, such as for structure strengthening or when raising crests or spillway height. Next, our case study. I choose this place as Walnut Lane Memorial Bridge. For the background of the Walnut Lane Memorial Bridge is the original Walnut Lane Memorial Bridge was a prestressed concrete ginder bridge in a Philadelphia designed by Belgian engineer Gustave Maginot and built by the city of Philadelphia. It's complete and fully open to traffic in 1945. This three-span bridge carried Walnut Lane over Lincoln Drive and Monocean Creek. It was the first major prestressed concrete beam bridge designed and built in the United States. When complete, this structure is symbolic of the integrity and ability of the engineers and builders who, during 66 years from 1885 until 1941. Okay, material for construction on bridge Walnut Lane. They can use concrete. The type of concrete is low slung concrete and energetic vibration. 50 mm maximum slump concrete was used. The rubber core that formed the dart in the thin web with, along with the reinforced steel in the web, reduce the effectiveness of internal vibration because only small vibrating heads could be used to avoid damage the rubber. Therefore, regular external vibration was needed, and it was hardly possible because of the effect on the foam. Second, prestressed steel. The type of prestressed steel, they can use stress relief wires. It is first use of the best quality single wire ever produced. It became widely used thereafter only to be suppressed. 3. Reinforcing steel. Furnishing and installing standard reinforced steel bar, the design did not call for syrup in the bottom flange of the ginder. In retrospect, this omission of syrup, particularly in the main ginders, appears to have been an error in judgment. 4. Formwork. The contractor chose to use wood. The use of wooden forms prevent the vigorous external vibration necessary to obtain the dense concrete free of honeycombs and cold joints that the loop slab would have otherwise produced. Last, chase for prestressing wires. The use of rubber core assemblies to form that chase that necessary for wire unit trajectory was ingenious and economical. Okay, next, method of construction on Walnut Lane Bridge. The construction team, for the step first, they used testing the first ginder. Preload personnel cast the 160 feet or 49 meters long test ginder on the western approach road to the bridge. The load test of the ginder was conducted in October 1949. Two longitudinal cracks appeared unexpectedly at about twice the total design load. One was on the surface of the ginder at the junction of the slope surface of the bottom flange with the vertical plane of the web. The other occurred in the surface of the ginder. Okay, we can see at the figure, it is appearance of the first test ginder after remove of the forms. Notes that diagrams were cast as part of the main span ginders. Okay, step 2 is the soft facial ginder. To maintain the required load slump of 2 in 50 mm, that the subcontractor had not mastered the concrete placing techniques required for low slump concrete was evident when the foam were removed after casting the first bright ginder. The surface ginder, honeycombs, cold joints in the web and bottom flange, larger and small holes, discontinuous and local displacement of the reinforced steel and chase were found throughout the entire length of the ginder. Serious consideration was given to rejection of the ginder after evaluating the alternative. It was decided to restore the ginder and to proceed with Prestressed. That's all from me. Thank you.